Hi, so I'm going to be talking about wet granulation of oral solid dosage forms for a batch size of 2,300,000 milligram tablets each. So to begin, wet granulation consists of these major steps. First, weighing of raw materials, then screen the materials into uniform particle sizes, blending the materials together until adequate uniform mixture, spraying binder solution to form small aggregates of particles, then wet milling, drying, dry milling, finally adding lubrication and other excipients like fillers and disintegrants, then putting these final formulation powders through a tablet press and optionally coating them for aesthetic looks. So first, weighing and screening of materials. Raw materials are weighed out according to their percent weights in the desired batch, and this can include the API, binders, lubricants, fillers, etc. And then for each 300 milligram tablet in the 2 million tablet batch size, we will be using 200 milligrams of API, 90 milligrams of filler, lactose, and 7 milligrams of disintegrant, which is 2.33% total weight, 3 milligrams of lubricant, which we will be using magnesium stearate, which is 1% of the total formulation weight. Using a high precision floor scale, as you can see in the picture on the top right, this model is from Mettler Toledo Supplier, and it's good for large weights. And below that, we will be using a conical mill by Nicomac, used for delumping and screening. The average mesh size will be 2,000 micron, and assuming granulated bulk density is anywhere from 0.5 to 0.7 kilograms per feet, the mill capacity must be 1,000 kilograms per hour because we only want to be milling for about half an hour. And since our batch is 500 kilograms, this mill capacity is perfect. And the purpose of the screening is to cut down particles to uniform size to prepare for more accurate and efficient blending. The next step, blending of raw materials. Blenders are used to mix raw materials into uniform mixtures. You can have tumble blenders, which we have chosen for our batch. For this specific tumble blender, we are using an intermediate bulk container. And like previously said, we're assuming bulk density of the batch of 500 kilograms. The max volume is 500 kilograms per 0.5 liters, which gives us a 1,000 liter. And this intermediate bulk container working capacity is 1,200 liters, which is good because we want the capacity to be only slightly larger than our desired volume. Next, we add the binder solution to the raw materials, and the binder solution we'll be using is starch. It is 5% of the formulation weight. If weight is assumed to be 500 kilograms, then 25 kilograms of starch is needed. And so for each 300 milligrams tablet, they will contain 15 milligrams of starch. And starch is 10% solution in water, so to mix with water, we would need 250 kilograms of water. Mixing vessel required is a 350 liter vessel with an agitator. Binder solution will create small little aggregates of particles, and as you can see in the picture on the right, it is like a snowball structure. Next, wet milling. Many types of equipment can be used, such as low shear mixers, high shear granulators, and fluid bed granulators. Low shear mixers are traditionally used, and the wet mass is passed through a screen to obtain uniform granules. The disadvantage of this is manual transferring of the materials, and sometimes you can lose a bit of the formulation, so it's not as efficient. And you have high shear granulators and fluid bed granulators. So for the purpose of this batch, we will be using a high shear granulator, and it will be coupled with a fluid bed dryer. So for this, the fluid bed dryer, in the model in the previous slide, warm air is used to dry the wet mass granules, steam pressure 0.4 to 0.6 MPa, steam flow 400 kilograms per hour, compression air pressure is 0.4 to 0.6 MPa, compression air steam flow is 1.5 meters cubed, and the blower and heater power is 45 kilowatts and 180 to 185 kilowatts respectively. Lastly, we'll do some dry milling, breaking up of the dry particles after wet milling, and this will help get uniform particle size in the end. And these are just some of the dry milling equipment: cone mills, comminuting mills, oscillating granulators. For this purpose, we have chosen a cone mill with the specs given below. Next, lubricants are added, and this will help to reduce friction, disintegrants to break down the tablet when in the body, and it is all blended in an intermediate bulk container that is used to collect the dry milling formulation from the previous step. Lastly, the final formulation powder is put into a tablet press. The powder is placed into a die cavity, and using upper and lower punches with a roller to compress tablets using force, the tablets are then ejected and sent out for quality testing. As you can see, for this batch, we've chosen a FE55 model from the FET supplier, which has a maximum tablet output of 626,400 tablets an hour, which would mean that it takes 4 hours to make approximately 2 million tablets. Thank you.